Okay. Hello, everyone. So this will be the first of what I hope will be many deep dives into how OpenSearch is written. We've had a few people uh, reach out on the OpenSearch Slack server saying like, "Hey, I'd really like to contribute to OpenSearch. It seems like a neat project, but the code base is so big, I don't know where to get started. Honestly, as someone who's been working on OpenSearch for about 2 years now, I can definitely relate. Like, yeah, after 2 years of working on OpenSearch, I frankly still find myself, figuring things out. Um, it is a very big project, a very big code base. Um, it's a lot of what we think of as sort of core OpenSearch um, is all in the OpenSearch GitHub project or in the OpenSearch GitHub repo, um, which is quite a large repository. So yeah, it's not that easy to get started, but I'm hoping that yeah, doing a couple of these little walkthroughs that it'll start to become clearer. Um, I figured doing vertical slices would probably be the way to go. Like so where we kind of go from the user down to the bottom of the system for a specific user action would help clarify some things. Um, and along the way, like this first one, stuff will probably seem overly complicated and uh there are a lot of layers. But the good news is that as we go through some of the later lessons, it's it, the layers are at least fairly consistent. So stuff that we see today, uh, we'll see similar patterns with other actions. So the action I want to start with is indexing a document. So I did do an earlier video, probably about a year ago, that talks about how OpenSearch gets started. From the public static void main through to where it actually constructs everything, um, that represents the OpenSearch process. The bulk of that actually, uh, so the bulk of that is in this constructor for the node class. So this thing is quite huge. Um, and so in that video from again about a year ago, you can find it on YouTube. Um, we went through this node constructor, and one of the final things was setting up the so-called REST controller with the REST handler. Um, and these various REST actions get registered. So I'm going to start from there. Um, so we're going to start from the REST index action. Uh, as I said, last year I kind of covered how these things get wired in, but a key piece is the actual REST URLs, are defined as routes. So to index a single document, the you can either use a post or a put, uh, and yeah, it extracts out the index name from the URL and the doc ID from the URL. So, um, why did I pick the index action as opposed to, for example, uh, deleting a document or better yet, the bulk action where the bulk action is where multiple index operations get processed at once. What we're going to see fairly soon, this is a slight spoiler, is that actually all three of these converge to the same spot. So, starting with the index action, though.
So that might just to jump in here, like why are there three ways to do the same thing?
Well, so indexing and deleting obviously aren't the same thing. One is creating a document, one's removing a document. Uh, the bulk operation is the somewhat more efficient way of saying, hey, here's a bunch of stuff. So instead of sending one HTTP request per operation, you say, hey, here's one HTTP request. I'm going to send you, I don't know, 5,000 operations. And then you let the server distribute things out to the various shards, and actually it can process them in parallel. Um, we're actually going to get into that a little bit, just because um, ultimately everything gets processed via the bulk path. Um, we're going to see fairly soon that the index action and the delete action actually get converted into single item bulk actions. So we'll get to see the bulk code soon.
But I guess the point I was trying to, like, let's say you have a single document with an ID. You've defined the ID and you want to index it. There's actually three ways you can do it. You can do a
Sure.
put on this URL, you can do a post, or you can put it in a bulk request.
True.
Um, some would argue that like having many different ways to do the same thing is like not great. But this code base is old and
Yeah.
it's been around a long time, so you'll often find like one obvious question is why allow both put and a post? Um,
Yeah.
and I don't know if there's a good answer to that. There's probably some historical reason why that's the case, but
Yeah.
if
So
for newcomers digging through this code, if you find a lot of this like complexity, like I guess it's kind of just a warning that there's a lot of
yeah.
complexity and some of it's just like legacy or probably
Yeah.
historical reasons why it's there.
Yeah. Yeah. Like I think with regards to the put and post, like historically, like the rest guidance is usually like a put is creating a new resource, whereas a post um can involve modifying a resource. But of course, we support this upsert type operation where you can, well, we'll see with the parameters here. Well, here's where the REST request gets parsed. Um, one of the one of the parameters is op type, um, which defaults. If we look at index request, jump to the index request class. The default op type is index, which essentially index means that well, let's look at the valid op types. Yeah, index, which essentially is kind of create or update, right? So create is specifically saying, okay, only create this document if it doesn't already exist. Update means update this document if it exists. And index kind of means, well, do one or the other depending on the whether the document exists or not. So that's probably why the yeah, it's both put and post because it may be creating something, it may be updating something. It's a surprise. Or yeah, it'll do either, depending on whether the thing exists or not. Yeah, so yeah, this is where we actually convert the incoming. So this is a recurring pattern for all of the REST actions. Um, that there's an incoming REST request where the REST request class models essentially just the HTTP request. Um, that HTTP request has to get converted into an operation specific request. And as you can see, this is done by hand, as opposed to, using an RPC framework, like gRPC or um, you know, honestly, I've lost track of what the popular RPC frameworks out in the world are other than gRPC. Yeah, that tends to be the dominant one on Java these days. Um, but nope, we don't use gRPC to do that conversion. We just do it by hand, by, reading out the HTTP parameters. So anytime that you see .param here, these tend to be URL parameters, either URL query parameters like question mark something, or in the special case of index and ID, they map to these positions. They map to these positions in the URL. So that's where those are extracted from. Um, it is worth noting that there is this special create case that's registered as a separate route. So what this does is if you do index slash underscore create ID, this is a shorthand for saying, oh, I want the op type to be create. Now, you can, um, oh, and specifically if you call the create URL with a different op type, um, then it'll throw an exception, right? That it's like you're not allowed to use this create URL with a different op type. Um, and funnily enough, this one supports both post and put. I would argue that in this case, it's actually incorrect from a REST standpoint because you're strictly creating a new entity. This should only be put. But again, as Andrew said, it's an old code base. A lot of this stuff has been around for quite a long time. If we do a git annotate with git blame, see when, well, okay, this was refactored.
Look at the oldest one though on line
Yeah.
78, 79.
Yeah, well, yeah, well, yes, actually, yeah. So in terms of, yeah, where the create handler was added in, yeah, that was in 2010. Where arguably, you could say 2010 was actually in the relatively early days of, what, of REST, right? Like the REST is um, not governed by any standards body to the best of my knowledge. I believe it's a not even really a standard. It's more just a way of doing things that kind of became a convention. So yeah, I would argue that in 2010 the Rust conventions were still relatively fluid. Yeah. Oh, before we dive a little bit more into the actual index request, there's also another extension of REST index action defined here, where this is the special case where you don't specify an ID in the URL. So you're just saying post, but this one's only a post because put, yeah, yeah. This one I think was done somewhat correctly in this, like, well, if you do a put, the expectation is that you should be able to access whatever it was that you put from the same URL. In this case, because you're just saying index underscore doc and not specifying a document ID, obviously you can't get back index doc because which doc are you talking about? So yeah, what this does, yeah, the expectation is that you're not specifying an ID, and then yeah, it's just ultimately it actually just delegates back to this, but accepts the idea that there is no ID. And in fact asserts that there is no ID. So okay, so now we get into where it actually prepares the request. Yeah, so it copies from the HTTP parameters into the index request object. And then the index request object here, so it outputs a REST channel consumer. So this is another fairly common pattern, um, for these REST actions, is that the real work happens in these prepare request methods that don't directly do the thing, but they return a function that, given a REST channel, will do the thing. Um, so it's essentially a little bit lazy. Um, so what it's doing here is it's saying like, okay, when you have the channel ready for me, um, we're gonna call client.index, passing in this REST request that we parsed out from the uh, with this index request that we parsed out from the REST request. And then when that's done, I want you to call this callback to convert that response back into a REST response. So this is a common pattern in OpenSearch where we start with REST-based communication and then convert it to what we call transport-based communication. So we end up using this node client. Um, so in in practice, this actually ends up not really being a transport request over the network, but often this client call ends up actually being just an in-process method call. It's we're going to dive into that. It's a little bit confusing. If it doesn't make sense, that's okay. We can, this is something that you don't need to understand too deeply to still be able to work on it. So this call to index, well,
I also think it's worth highlighting you may be going to get into it, but this whole listener pattern, there's lots of way to do asynchronous code, but the way that and asynchronous programming is pervasive throughout this code base, and it's almost always through this listener pattern where you pass in a callback
yeah,
to something happens asynchronously, you pass in a function to be invoked when it's done.
yeah,
More modern code tends to use something like the completable future or
yeah,
similar, but not here. It's all this listener callback.
yeah, yeah, and it's worth noting. So, a lot of these sort of transport actions, anything that you get from this client, um, tend to have like, oh, here's a request object, and we get back a response object, and you pass in your essentially your callback, your action listener that says, what do I do with the response object? I glossed over this. Um, what's happening here is um, the REST requests use this X content. When you see the word X content, you can kind of tell yourself JSON. It's not just JSON though. X content actually has multiple supported formats. It's JSON, YAML, Smile, CBOR. Um, but in practice, you can kind of simplify it for yourself by whenever you see X content, kind of think JSON. So this is converting back from this index request object back to a JSON or YAML or whatever response, depending on the content type header set in the HTTP request. So um, so a lot of what goes into this abstract client here. Um, is essentially, kind of mapping individual convenience methods into various forms of execute. Um, so execute is this all-in-one do a thing method, um, where as the Java doc here says, this is the single execution point of all clients. Um, so the yeah the idea is that um yeah we funnel everything through here, and it all works via this registry concept. Like if we dive into do execute, yeah, node client. So this is so in practice, the instance of abstract client that we have here is what's called node client, and it calls this execute locally. Well, execute locally looks up the transport action given the action type and then executes it. Well, how does it do the lookup? Well, it has this thing called action registry. So it says action registry, get the action for the given action type. And then, as we saw, once the action type is found, then we call its transport action specific execute method. Yeah. Talking about this generically may seem very confusing, but if we look at the specific case of index, so the action type is index action.instance. Let's look at where that gets registered. So this thing gets used. So that talk that I gave a year ago about how everything gets wired up, if I recall correctly, one of the last things I talked about was action module, where there's this big method, set up actions. Um, so again, there are discovery mechanisms. There are ways to do things via injection. Instead, it's like, nope, this is the explicit code where each and every action type gets registered in the action registry. Um, and so, yeah, as you can see, the action type of index gets mapped to transport index action. And essentially, yeah, this is saying, um, yeah, going back to the node client here, where it does this resolution, it's saying, okay, well, if I get action type dot index, or sorry, index action dot instance. Yeah, that was it. Yeah, index action dot instance. Then yeah, it's going to map that back to transport index action. So this is the real thing that that does the work. So these transport actions, uh, well, the base transport action class has an execute method, which we kind of jump back here. See, so we resolve the transport action, we call the execute method. Um, and yeah, let's get into how that gets called and what it does. So, transport index action, as I mentioned earlier, um, in practice, transport index action actually extends transport single item bulk write action. So this was a refactoring that was done. So you see, this class is officially deprecated, but it was, let's see when it was deprecated. It was a while back. 2016, right? So almost 8 years ago. Transport index action was marked for deprecation, saying like, oh, okay, well, actually, we can just do this single item bulk write action. Um, in practice, like, fully deprecating it may not be that necessary. This constructor is a little bit convenient, right? So the fact that um it ends up calling into the transport single item bulk write action with the appropriate saying like, oh yeah, I'm associated with index action and you know, incoming requests, or sorry, that you can create a request using the index request constructor.
So, Michael, is there any exact plan to totally deprecate this transaction bulk write action?
Well, or the transport index action.
Yeah.
Um, Probably not. Like again, like this was marked for deprecation 8 years ago. Um, honestly, it stuck around for a long time, like multiple major versions. Um, Even before we forked OpenSearch. So, honestly, this thing's not really hurting anyone. I do appreciate having the deprecated annotation so that if for some reason somebody were to code against this, then they would say like, oh, okay, well, rather than extending this directly, maybe I can extend the parent class.
Ah, okay.
Yeah.
I
Yeah.
think Elasticsearch still use this deprecated code until
I
now.
I have no idea.
Yeah.
But yeah. Yeah, all I know is the code base that we have. But yeah, let's look into the single item bulk write action. As you can see, so this thing um it's essentially a bridge. We look at who extends it. See, so both transport delete action and index action have been marked for deprecation. Transport delete action looks almost identical. The transport index action, it's just, passing in these slightly different constructor parameters, right? So, yeah, so we've got the request reader and the action name that are being passed up from the subclasses. Um, and they take an injected bulk action that they're going to delegate to. Um, and essentially, like the real work of this class is to say, I have one operation and I want to turn it into a bulk request, essentially by, instantiating a bulk request, adding my single operation, um, lifting up some request level parameters. So the refresh policy, the timeout, the wait for active shards. Um, so these kind of get lifted from that inner request up to the bulk request layer. And then, yeah, that's the bulk request that we're going to process. And we talked about how, the responses always get passed through these callbacks. Well, we're going to get a bulk response, right? If we do a bulk action, we're going to get a bulk response, which has a collection of responses for each of the individual things that we did. Um, but obviously, this is a single item bulk action. So we need to unpack the single item, right? And pass that, right? Because if we do an index action, it's expecting to get an index response. And so, if we were to send back a single item bulk response, like a bulk response with one element, um, that would be surprising. So we should unpack the the single item from the bulk response. Cool. So that's, this is essentially an adapter. Oh, we can see that even this one was at some point marked for deprecation, saying, no, 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 don't use this adapter. Use bulk action directly. Um, Now that's obviously a much bigger change because then you're actually changing APIs, right? Like this thing is maintaining backwards compatibility with these index and delete APIs. Uh, yeah, I'm frankly a little bit surprised that this one's marked for deprecation because that would actually be quite a significant change. Uh, it was marked for deprecation a day after the individual items were marked for deprecation. Those going away could maybe be done. Because it's mostly just internal code changes. I don't think this one can reasonably go away because that would actually break the index and delete APIs, which yes, most people in production just send everything via bulk. Um, but there are enough people who use the index and delete APIs directly that I don't think it's feasible to take those away. So anyway, so I alluded to the fact that these transport actions all have an execute method. Um, well, I can sort of search for uses. Yeah. So transport action, you can see, yeah, it's a little confusing. I think I will just kind of gloss over this part. So the base transport action ends up ultimately, yeah, in its execute. There's this whole task notion, um, where where is it? Yeah, somewhere in here, in yes, yeah. So it's when we execute the task, we end up creating this request filter chain, and we call request filter chain dot proceed. And part of the request filter chain dot proceed is that we end up calling do execute. Um, so the punchline of that slight diversion um, is that, yeah, for most of these, for most transport actions, the do execute method is where the body is found, right? So this is all the generic top level base class for transport action, but in individual actions, when you want to get into their subclass specific behavior, look at do execute. So in this case, what we do is we delegate to the bulk action, right? So this is where we've wrapped up the incoming request. We attach the listener that unwraps the response, and then we delegate to bulk action. Cool. Now, as I just said, the execute method is generic. So when I click on this, I think it'll actually take me back to transport action. Yep. So that's not what I want. What I want is to go to transport bulk actions do execute method. So at this point, we're in the class that handles bulk requests. If we had come from REST bulk action instead of REST index action, we would end up here the same way that we got here via REST index action. REST bulk action also ends up routing here via that action registry, except in that case it would look up the bulk action dot instance, which is mapped to this transport bulk action in the action registry. But yeah, so this is where my argument at the beginning that it doesn't actually matter that much if we come from index, delete, or bulk. It all ends up here. So if we look at this thing's do execute, this is where I'm just gonna pull up my cheat sheet that I've got in another window. I have a lot of notes on transport bulk action. As I was diving into this on Friday, I was like, oh boy, there's a lot of stuff going on here. That this most of the classes that we've been in up till now, you know, like I would argue the transport single item bulk write action is the longest that we've looked at so far. It's 100 lines. Even REST index action. Well, REST index action's like 168. Mostly that's because we have the auto ID special case and we have the create special case. These are just convenience methods. Um, yeah, transport bulk action. Let me go back to it. Yeah, transport bulk action. This thing's actually quite a big class. It's 1,000 lines, and it's doing quite a lot. Um, Starting with the do execute. So one thing that I learned doing this code dive. Um, First check that we do is, well, keep in mind, like from here on out, we're expecting that we're processing multiple items. Like from the code path that we dove into, yes, it is a single item, but in practice, this is one or more actions in the bulk request. So, assuming there are multiple actions in the bulk request, we look through all of them, and this is only system is a helper that, yeah, just iterates through all of the indices present in the bulk request and checks um, are all of the actions on system indices. So OpenSearch can reserve special indices to say, um, I'm storing data here. Um, to a little to some extent this does feel a little bit like a relic of its time. So back, sort of 14-ish years ago and going back a little bit further, right? Some of you may remember the old like lamp stack, right? Where people would build stuff with Linux, the Apache web server, MySQL, and PHP or Perl, depending on what P stood for, right? And the whole idea back then was, oh, I have some data, I'm going to store it in a relational database because that was what people were used to, and MySQL was the preferred open source relational database of the time. Um, to some extent, these system indices are I have some configuration data. I need to store it somewhere. Oh, I'm going to store it in an index. Because yeah, I have the system that um, happens to be able to store a search index. And so if I internally need to store stuff, I'm going to store it in a search index. Um, it feels to me like a little bit of an abuse of a search index. Like these kind of config system indices, um, arguably like you could just, I don't know, embed SQLite. Like, yeah, this is something where an actual database might actually be more appropriate than piggybacking it on Lucene, but this is the choice that was made. So anyway, so there's this concept of system indices. If every request within the bulk request is on a system index. Um, we use a different thread pool, right? So these executors, this is which thread pool do I actually want to process stuff on? Um, I didn't know until, you know, I dove through this a few days ago that yeah, there's a dedicated system right thread pool. Um, that I my understanding is that this is to make sure that if you have a request that's coming in and needs to modify a system index, um, it can't get crowded out. It can't get starved by regular doc indexing requests. Um, yeah, so even though it all gets, the system index updates get funneled through the same code path, it says, nope, you get your own thread pool. So yeah, interesting idea. Uh, we also have this call out to um, indexing pressure service. I don't want to go into that today, but if we see the key thing here, as I understand it, yeah, if this is where we end up rejecting things um if we're using too much memory on a coordinating node, um then yeah, this is sort of where an indexing request will get rejected. Um if we're sort of sending too many indexing requests. Um, Incidentally, this stops becoming an issue if you do pull-based indexing, which is something that's coming soon. It's being actively worked on in the community. So yeah, but yeah, okay. So this is essentially what's happening in DoXQs. That you've got the indexing pressure service to potentially reject these things, and we're choosing which um, which thread pool we're going to use. And then we call into do internal execute. Um, Now, in practice, does this do internal execute method need to be a different method? Could it just be inlined here? It could be. But on the other hand, it's pretty big. So inlining it, yeah, I kind of appreciate the fact that it's split out into a separate method. Honestly, uh, I think this do internal execute could be broken down further. Um, so this does several things. Um, a good chunk of it is related to ingest pipelines. So this is where the logic. So ingest pipelines allow you to modify indexing operations as they come in to um, as they come into the cluster. So the coordinating node, the node that received the index request or the bulk request, um, it will either execute the ingest pipeline or it will delegate. We'll see that shortly. But first, it has to iterate through all the requests and check, hey, do any of these um, have a pipeline associated with them, right? And so it'll delegate out to this ingest service resolve pipelines. Um, so yeah, it'll check um, either. So yeah, this resolve pipelines. I'm not going to dive into it. It's either saying, hey, does this index request specify, oh, please process me with this pipeline, or do we have an index setting to say for this index, please transform every request using this pipeline by default. And so, yeah, this takes care of either of those. Um, and yeah, it's doing an or equals. So if any request uh, needs to pass through a pipeline, then it'll say, okay, we're going to go through the pipeline code down here. Um, but yeah, if none of the requests have an associated ingest pipeline, in practice, yeah, ingest pipelines are kind of hit and miss as to how much they're used. We've added some neat stuff recently to be able to process to do ML inference using ingest pipelines. Other than that, I don't know how frequently they're used. People often the recommendation for a while has been you should probably process your stuff before you send it to your cluster anyway. Um, Passing requests to the cluster just to let the cluster modify them is maybe not the best use of resources. Let the cluster do the indexing while you do your pre-processing outside using something like Data Prepper. But you can still use ingest pipelines. So if any of the requests within the bulk request has an associated ingest pipeline, this is where, okay, so do some, if we've got assertions enabled, we make sure that's like, okay, well, every pipe request should have a resolved pipeline. Um, as they say, uh, yeah, so this method will be called again. Um, yeah, so uh at the very least, yeah, if we end up here, every request that didn't have an associated pipeline is actually associated with the no op pipeline. So yeah, that's just what this is asserting is like, okay, everyone should have an associated pipeline. You don't just have some elements with pipelines resolved, everyone is resolved. So I alluded to the fact earlier that so the coordinator may process the ingest pipeline directly. So that happens here in process bulk ingest request. So it can do that um, if the current node has the ingest role, which it does by default. By default, every data node has the ingest role. Otherwise, we end up needing to forward it to a dedicated ingest node. And interestingly, if that's the case, the current node is done essentially. That you know, well, done except insofar as its listener will get called on the way back out. Um, but actual processing is done on this node that says, oh no, I'm going to delegate out to this ingest node. And yeah, it's going to do the rest of the stuff. And then when it's done, it's going to call back to my listener, and then I'm going to respond back to the client. Um, so yeah, we don't need to go into the details of processing ingest pipelines. That could be for another day. We're starting to run a little bit low on time, and we're still processing a bulk action. This bit here, I just want to touch on just because again, this is code that was new to me when I started to dive through this. Um, so summarizing this big, if else. So, um, by default, we will auto create indices. Um, so if a bulk request comes in and there's an index request for an index that doesn't exist, the default behavior in OpenSearch is to automatically create that index. Um, this provides a good out-of-the-box experience where people can just install it and then start sending documents. Um, I would argue that auto-create indices, in my opinion, should probably be turned off in production. Um, Auto-create indices and dynamic assignment of mappings, in my opinion, are a bad idea. Um, imagine you're talking to a database administrator and you say like, "Oh yeah, I want a database system where somebody can do an insert." And if the table that they're trying to do an insert into doesn't exist, I want you to just create the table. Which the database administrator would probably say, but how can you do that? What would the schema for the table be? And you say, oh, well, no, that's okay, because when you do the insert, you can just look at the columns in the insert statement and just make up the schema based on those columns. Oh, and if I send another insert for the same table, and I reference some other column that doesn't exist, in the table, just add that column on the fly. Of course, that database administrator would probably quit their job if their boss asked them to do that because this this sounds like a terrible, terrible idea. Unfortunately, this is kind of the default behavior in OpenSearch. It's longstanding behavior. People rely on it. We probably can't change it, but you can disable it in your cluster settings, right? You can disable auto create indices. You can disable dynamic mappings. You can create your own indices explicitly and give them specific mappings. Um, that to me is a better idea in a production environment. That you should be saying, I expect this index to exist. And I expect it to look like this. But in the meantime, we need to be able to handle all this auto create logic. Well, apparently, when the setting was added uh, to to allow people to disable, so incidentally, this need to check, right? If auto create index dot need to check is set, where yeah, need to check is a poorly named helper that is saying like, well, if auto creation is enabled, right, then we should go in here, or if there are any system indices. Now the funny thing is, I thought I remembered curiously. Yeah, no, this is a Boolean, and yeah, it's mapped to this setting. Um, I thought that. So interesting. We're going in here if. Um. Okay. Yes. 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 Okay. Now I remember. So if there are no system indices and auto create is disabled, right? So remember, need to check is just a confusingly named alias for autocrate is enabled. So if there are no system indices, none, like this isn't that earlier logic that's saying if there are only system indices, this is saying if there are any system indices. Um, so no system indices and autocrate is disabled, we go into this else block, right? So we just execute the bulk request. That's it. Um, if there are system indices, or we may be auto creating, then what we have to do is we iterate through all the bulk requests again. Um, and so we collect all the indices that are in the request. Um, step two, right? We figure out which indices don't exist yet. Um, by looking at this should auto create. Should auto create really could be named probably like, does this index exist? Anyway, or yeah, should auto create is essentially the index doesn't exist. Now, there's the reason why we have this include system check. Apparently, early on, when the auto create setting was thrown in, people developed plugins that depended on having system indices to store their state, to store their configuration. But then those wouldn't work in cases where people had disabled autocreate, right? If you disable autocreate, well, you still want your plugins to work, and your plugins probably or may assume that it's like, oh, if the system index doesn't exist, I can just create it by indexing something. And so yeah, that's why system indices are a special case. So you can always auto create a system index even if you've disabled auto creation. Anyway, if there's nothing to auto create, we call the same execute bulk, right? So this execute bulk, almost the same. The slight difference is that we do pass in this hint of indices that cannot be created. So this will be non-empty if auto create indexes is false. And there were some non-system indices that should have been auto created. And those operations actually get filtered out. Anyway, otherwise, we do need to auto create some stuff. And so what happens here is we call create index, and then the callback to that. We have these similar callbacks in on response and on failure, where this is sort of a fairly standard pattern when you're fanning out asynchronously. Um, is you say, hey, I want to asynchronously do n things. Um, and what I'm going to do is in each callback, we're going to do this decrement and get. So basically, as each of these create index requests comes back and responds, they're going to say, okay, there's one less thing to do. Now, you have to do that both in the success case and in the failure case, right? Because some of the requests may succeed, some of the requests may fail. If a request fails, what we do is we actually null out the action from the bulk request. So we say, no, actually, we're not going to do the actual index operations on this index because we failed to create it. Um, and whether success or failure, if you're the last create index request, you'll be the one who decrements the counter to 0. And either way, uh, let's look at the happy case. Yeah, the on response. So we're gonna delegate back to the original thread pool. Remember, this is the write thread pool or the system write thread pool. And we're gonna execute the actual bulk operation. Um, and yeah, that actually brings us to the end of the hour. So I think, yeah, I'm gonna leave it there for now. Um, I'll schedule the next one hopefully very soon, maybe even later this week. And we'll continue. We'll get down to execute bulk and hopefully reach uh the point where we actually index something. So far we haven't left the coordinator node. We've gone from the REST request into transport index action, which which inherits from transport single item bulk write action, which is a wrapper that converts a single action into a bulk request and translates the bulk response back into a single item response. And then we spent a decent amount of time in transport bulk action looking at looking a little bit at system indices, looking a little bit at the logic to hook in with ingest pipelines. And now we spent a little bit of time looking at the auto create logic. Yeah, next time I'll try to go a little bit faster as we get through execute bulk and the we will soon leave the coordinating node. Just to give you a slight preview. What happens with a bulk request is that we hit the coordinating node, which is whichever node the request got sent to by typically a load balancer or by the client picking a random node in the cluster. Um, so that coordinating node will look at the individual requests and figure out which primary shards they need to get routed to. And those will get dispatched asynchronously, and we're going to wait for their callbacks. So yeah, that'll be for next time. And then we'll land on the primary shards, and we'll dig down into how the primary shards record to the transaction log and finally write to a Lucene index. So thanks a lot. I hope this has been useful, and yeah, we'll see you next time.
Thanks, Michael.
Thanks. Nice.
Thanks, Michael. Thank you for your time.
Okay. See you next time. Thanks.
Michael.